Hello students, welcome back to the 8th video of this playlist. So in this video, we will be solving question number 8 from January 2024 Pure Mathematics 2 paper. So let's see what question number 8 is about. So basically, the concepts behind question number 8 is from the very first chapter of your Pure Mathematics 2 textbook, which is what? Proof. Chapter number 1 is algebraic methods. So in this topic of this chapter is proof. Okay. So to be more specific, we need concepts from proof by exhaustion and counterexample. So let's get started with question number 8. Part 1 asks to use a counterexample to show that the following statement is false. Okay, what's the statement? This is n squared plus 3n plus 1 is prime for all n element. What's that? Natural numbers. Okay, so what are natural numbers? Natural numbers are basically 1, 2, 3, 4, 5. All the positive integers are natural numbers. Okay, except 0. 0 is not a natural number. So we need to disprove this statement. Counter example, counter, the word counter itself says it's what? It's giving an example that is opposite, right? So let's consider that. We should give an example. So we should consider a value of n such that n square plus 3n plus 1 will not be prime. Okay. At first, let's try n equals to 1. So 1 plus 3 plus 1, which is 5. 5 is a prime number. Okay, so it's reject this one. 2. 2 square is 4 plus 6, which is 8. 8 plus 1, this is what? 3 times 2, this is 6. 6 plus 4, this is 10. 10 plus 1, this is 11. Okay, so 11 is a prime number, so reject. Next is 3. So 3 square is 9. 9 plus what? 9, which is 18. 18 plus 1, which is 19. 19 is also a prime number. Okay, so what if we consider 5? 25 plus 15, which is 40. 40 was giving what? Prime numbers. Okay, 6. 36 plus 18, which is 54. 55 is not a prime number. Okay, if we consider 6, 6 squared is 36. 36 plus 18, this is basically 54. 54 plus 1, this is 55. 55 is not a prime number. That means what? Consider what we can consider here. We can consider uh, n equals to 6. Then what? N square plus 3n plus 1 equals to what? 36 plus 18, which is 54 plus 1, which is 55, which is what? Not a prime number, isn't it? Not a prime number. Okay, so hence it has been disproved that what? Uh, they said n square plus 3n plus 1 is a prime number, is prime for all n element natural numbers. It has been disproved. That's it. Proved by counterexample. Okay. Okay. Next is part 2. In part 2, they're asking to use algebra to prove by exhaustion that for all n element natural numbers, n square minus 2 is not a multiple of what? 4. Okay. We need to use proof by exhaustion. What is proof by exhaustion? In this proof, that is in proof by exhaustion, what we need to show? We need to show that the given statement is true for every possible single cases. Okay. So that means if we are able to show that this statement is true for all possible numbers, that is natural numbers, since they're considering natural numbers, then we are done with the proof. Okay. So it's really difficult to consider all the possible numbers here. So we will consider some expressions for the ease of approach or ease of algebraic method. So what we will consider is that natural numbers. Natural numbers can be even or odd. For even, we will consider an expression. For odd numbers, we will consider another expression. And using these two expressions, we will show that this statement is what? True. Okay. 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 So for part two, even what we can consider? Consider n equals to twice of k. So if n equals to twice of k, then n squared minus 2 equals to what? 2k whole squared minus 2, which is 4k squared negative 2. Fine. So 4k squared minus 2 is what? Is it multiple of 4? No, because 4 times k square here, what? 4k square is a multiple of 4, right? Is a multiple of 4, but what? 4k square minus 2 is not. Okay, so for the first case we have showed that if n is even, then n square minus 2 is not is not a multiple of what? 4. And next, consider second case. That means the first step is done. That means we have proved for all even numbers. Now remaining is what? Odd numbers. Odd numbers you will consider n equals to twice of k plus 1. Okay. Then okay, 2k plus 1. Why I am not considering 2k minus 1? It's a good question. If you consider 2k minus 1, you will see that for k equals to 0, you will get the value for n, it is negative 1. Negative 1 is not a natural number. Okay, so that's why we should consider 2k plus 1. Okay, so n square minus 2 equals to what? 2k plus 1 whole squared minus 2, which is 4k squared plus 4k plus 1 minus 2. So you will get 4k squared plus 4k plus 1 minus 2, that is negative 1. Okay, so we can show here, take 4 common, so k square plus k, like you need to do the algebraic workings according to the question what they have wanted. Okay, so that's what I'm trying to do, negative 1. So easy pattern that here what? 4 times k square plus k. K square plus k is a multiple of 4, but what? 4 times k square plus k minus 1 is not. Okay, so for even numbers, we got that not a multiple of 4. Odd numbers, we also got that n square minus 2 is not a multiple of 4. So done. For all possible cases, we have already showed that n square minus 2 is not a possible, not a multiple of 4. So what we can write now? Hence proven what? Hence proven that for what n element natural numbers, n square minus 2 is not a multiple of 4. Done. And that's what part B, part 2 of question number 8 has asked for. And that's the end of question number 8.